Yes. So these were the things that we had taught in the last class. Uh, we talked about all the numbers, the number of elements in the set, and then we talked about the summations, how to calculate the summations of first and natural numbers, the summation of squares of first and natural numbers, summation of cubes of first and natural numbers. ये सबके formula हमने देखे थे shortcut में, and we also solved some of the questions. Then we talked about the progression, the arithmetic progressions, the geometric progressions, and the like ये दोनों progressions के बारे में पढ़ा था, and इसके अंदर हमने दो चीजों की बात की थी, the nth term of an progression and the sum of the progression, sum of elements of a progression. ठीक है. So and then we talked about a special topic of this infinite geometric progression, जहाँ पर we have जहाँ पर हमारी जो common ratio जो होता है उसकी value जो होती है that is less than 1, right? Then we talked about mean, median, mode. Inside mean we talked about the three types of mean: arithmetic mean, geometric mean, and harmonic mean. Median and mode, ये चीजों की बात पढ़ी थी, and we also understood the relationship between arithmetic, geometric and harmonic mean. ठीक है, ये तीन चीजें हमने देखी थी. Then we started with the algebraic identities, जो basic identities जो हम use करते हैं बहुत ज़्यादा, उनको हमने discuss किया था, and we took some of the examples. We talked about how even and odd numbers they interact with each other. तो जब हम even number को even number से multiply करते हैं, plus करते हैं, और we raise the power, उस case में क्या होता है, that we talked about. Then we started defining HCF and LCM, वो define किया. Now in today's class we'll start with the next topic, and your next topic for today is going to be the cyclicity. आज नया टॉपिक होगा, वो होगा cyclicity. Let me start with the next topic. Now this is an important topic, important in terms of understanding कि होता क्या है. In while solving some of the numericals we'll talk about it कि इसको use कैसे करना है. But for today's class I want you to understand कि ये होता कैसे कैसे काम करता है. ठीक है. So what is cyclicity? Basically ये बताता है कि any unit digit, right? The repetition.
Excuse me, sir. One request, sir.
Yes, please.
Sir, can you please try to talk in English much only? Like we can't understand Hindi that much, sir. That's
Okay, fine. Fine. I'll be talking in English and Hindi both. Not an issue.
yeah. Okay, sir. Thank you, sir.
Okay. Fine. So cyclicity is basically the repetition of unit digit when a number is raised to certain power. So when we raise the number to certain power, the unit digit repeats itself, and that is known as the cyclicity. For example, I will talk about the cyclicity of each of the digits. So if you have something whose unit digit is 1, let's we'll talk about 1. Now these are unit digits. I'll just repeat it. These are unit digits. So let's take it like this. If the unit digit is 1. Now what does that mean? If you have 1 as your unit digit, so what will be 1 raised to 2? Yes, what is 1 square? 1, right? Similarly 1 cube is also going to be 1, or you raise to any number, right? You raise to any number, it is going to be 1. So from here I can say that the cyclicity of 1 is 1. What does it mean? Basically, if you take the power of 1 raised to 1, you will get 1, right? Again 1. Now before 1 we'll go to 2 and we'll try to understand what is cyclicity, then I'll come back to 1 again. So let's talk about 2. So you know 2 raised to 1 is
2.
right. Now I'll just increase it. Now kindly notice the unit digit over here, it's 2, right? Now 2 raised to 2,
4.
2 raised to 3,
8.
2 raised to 4,
16.
and 2 raised to 5,
32.
32. Now again I want you to notice this unit digit over here. It was 2 and it again becomes 2. So after every four powers, the fifth power again becomes 2. Right. So over here you need to understand what is the cyclicity of 2. The cyclicity of 2 will become 4. Right. In case of 1, it becomes 1 because after every power you will get 1. Right. But cyclicity of 2 becomes 4 because after every 4 power, the fifth power will again become 1. Now, why this kind of thing is at all important? Is zaruri kyun hai? Why we need this kind of things? Let's try to understand. Let's say you want to find out 2 raised to 29, or rather than, let me be precise with the question. The question goes like unit digit of 2 raised to 29. Yes. So what I'll do is I'll first of all identify. I'll first of all divide this 29 with 4. So the nearest number that I get is 28, right? So I'll just separate it 2 raised to 28 and 2 raised to 1. Now I know after every 4 it will repeat itself. So after 28 it will repeat itself. So again you'll get only 2. So the answer will be the answer. See, this will just cancel out because this does not make any sense. Right? ये जो 2 raised to 28 है, it will not make any sense because after every 4 it is going to repeat. It will start from 2 only. So after this 28 also it will start with 2 and you'll get only 2 over here. So the unit digit will become 2 in this. Right. So cyclicity is important to understand after how many powers the unit digit is going to repeat itself. Right. We'll solve some of the questions about it. Don't worry later on. So let's talk about 3. So we know that 3 raised to 1 is 3, 3 raised to 2 is 9, 3 raised to 3 is, yes, anyone who can tell me 3 raised to 4,
80.
81.
81. See, we started with 3, so I'm searching for 3 as a unit digit and I haven't got 3 as a unit digit over now. 3 raised to 5,
343.
243.
243, sir.
243. See, try to understand it in such a way. You have at 81 over here and you have to multiply 81 into 3. See, we will just perform quick calculations. We are not going to rely on calculator. So what I'll be doing is I'll be multiplying 80 with 3, I'll get 240. I'll be multiplying 1 with 3, I'll get 3. So the final answer will be 240. Right. So 243. Now you can see the unit digit is getting repeated over here. So we started with 3 and after 1, 2, 3 and 4 powers, we again get 3. So after every fourth power, the fifth power will be 3 again. So cyclicity of 3 also becomes similar to 2.
4.
4. Right. So you need to be careful about determining the cyclicity of 2 and 3 specifically. Right. Rest of the numbers, they are simple. Let's say if I talk about 4, we can easily determine the cyclicity of 4. How? We start with 4 raised to 1, which is 4. 4 raised to 2, 16, and 4 raised to 3 is
64.
64. See, again, the 4 is getting repeated after first, second, and the third one again becomes 4. So it is getting repeated after every 2 powers. So the cyclicity will become
2.
2. Let's talk about 5. So 5 raised to 1 is 5, 5 raised to 2 is 25, 5 raised to 3 is 125. In any case, the unit digit does not changes. So you may raise it to any of the power, but the cyclicity of 5 is going to be 1 because after every power it is going to be 5 only. The unit digit it is not going to change. Let's talk about 6. 6 raised to 1, 6, 6 square, 36, 6 cube. Yes, anyone who can tell me what is 6 cube?
2 and 6.
Very good. So again, if you see the unit digit is not changing at all, the unit digit is not changing at all. So the cyclicity of 6 will also be 1. 7. So 7 is to 1 is 7. 7 square is, what is 7 cube?
343.
Very good. 7 is to 4.
2401.
Great. 2401. That is basically 49 square. And 7 is to 5.
16807.
Yeah, that's true. 16807. So you can see the unit digit getting repeated over here. So we started with 7, and after 1, 2, 3, and 4, we get 7 again. From here again, we can determine the cyclicity of 7 to the 4. See, this cyclicity is to be remembered. To be very frank, you are not supposed to calculate it every time. This is just for understanding the basics. But you are supposed to remember the cyclicity because it will help you out in solving many of the questions. Right, so you can solve them directly. You are not supposed to calculate it every time. Now let's talk about the next one, 8. So 8 ones are 8, and 8 square is 64. What is 8 cube?
512.
512. Again, it is not getting repeated. 8 raised to 4,
4096.
4096, and 8 raised to 5 is
32768.
768. So now over here the unit digit is getting repeated. We started with 8, 1, 2, 3, and again after 3 or 4, you can say it gets repeated. It gets repeated. Over here, the cyclicity of 8 is 4. Let's talk about 9. The cyclicity of 9. 9 is to 1 is 9. 9 square is 81, and 9 cube is
729.
very 729. So you can see we started with 9, and in the third step we got 9 again. So cyclicity of 9, it is just 2. After every 2, it will again become 9, and for 10 it will become 1, and subsequently it will become 1 only. Right, supplementary or successively, if you move on to the next numbers, the cyclicity depends only on the unit digit. It does not depends on the previous digit. It only depends on the unit digit. So even if the number goes like this, so 1 5 6 2 9 2, so even this kind of number is there, the cyclicity you can determine with the help of the unit digit itself. Okay, so if the 2 is having the unit the cyclicity of 4, this number will also have the cyclicity equal to 4. Right. So this is cyclicity. We'll talk about the use of cyclicity later on when we'll be solving some of the questions. But up to this, you should be clear like what is cyclicity. Now, next most important topic from this chapter, which again is going to help you out a lot, is divisibility tests. So let's talk about the divisibility test of each of the number. We'll start with 2, which is basic even, right? So what is the divisibility test over here? The unit digit of the number. If the unit digit of the number is 0, 2, 4, 6, or 8, it is divisible by 2. For 3, we are using this divisibility test since a long time, the sum of digits. The sum of digits of number is divisible by 3. Then the number itself is divisible by 3. Let's take a simple example. 3, 2, 4, 9, 6, 5, or 6, 5, 4, 7. So let's add it up. You'll get 3 plus 2 plus 4 plus 9 plus 6 plus 5 plus 4 plus 7. Yes, can anyone tell me what is going to be the answer?
40.
40, 40. Right. Again, this 40 you can write down as 4 plus 0, which is 4. Now, since 4 is not divisible by 3, this number is not divisible by 3. Right. So from here I can write down that it is not divisible by 3. So this is applicable for 4x and as well as this number also, right? For both of them, they are not divisible by 3. Now next, the divisibility test of 4. So for the last two digit numbers, the last two digits, right, of the number, it should be divisible by 4. If the last two digits are divisible by 4, the entire number is divisible by 4. Or there is one more condition, or the number is 0, 0. Right. For example, if you talk about a difficult number, let's say 2, 4, 9, 6, 5, 2, 5, 8, 4. Right. So if the last two digits of this number, like 8, 4, if it is divisible by 4, then this number is divisible by 4. That is first condition. Or if you get like 2500, if someone asks you whether this is divisible by 4, yes, it is divisible by 4 because you have two zeros. So it is divisible by 4. Next, the fifth one, the 5. So if I take, oh sorry, it should be fourth one, right? Should be fourth one, the 5. So for the 5, it's simple. The last digit should be either 0 or 5. That we know very well. So I'm not going to explain it much. Right. Then 6 is a combination of 3 and 2, 7. So 7 is a thing which where you need to divide the entire number, right? This is a common thing that which we do. We divide the entire number by 7. If we get remainder, then it is not divisible. If we don't get remember, it is divisible. But there is one more method. Let's talk about it. What we'll do is we'll remove the last digit. Remove the last digit of the number. Then what we'll do is we'll double the numbers. We'll double it. The last digit, we'll double it. And what we'll do is then we'll subtract it from the rest of the numbers. We'll subtract it from the rest of the numbers. Once this is done, we'll repeat it. Right. We are supposed to repeat this whole procedure until we get an alternative, that is a one digit number. Until we get a one digit number. If that number is either 0 or 7, then it is divisible by 7. I know it is not much clear, so we'll try to solve it with the help of some example. So let's take certain example. Okay, over here I want an activity from your side. So who will volunteer? Who has a calculator with them? Right now? Anyone with the calculator in their hand? No one.
Yes, sir.
Okay. So I'll take you as a volunteer. Pawan, right? Okay, fine. So what I want is I want you to take any 5-digit number, any of the 5-digit number of your choice,
Okay, sir.
right? And then multiply it by 7 and tell me the answer.
Sir, the 5-digit number is 5678 or 798.
Okay, and the answer that you get after multiplying by 7 is
That is 397586.
397586. Okay, thank you so much. So yes, now what we have done is I've taken a number which is actually divisible by 7, and we'll try to test it with the help of this method that we had discussed earlier, that whether it is actually divisible or not. Right, so we know that it is divisible as per the calculator, and we'll try to check it with the other method. So first of all, I'll remove the last digit of the number. So what I get is 6 will be removed, and I'll multiply it by 2. So I'll get 12. The remaining number goes 39758, and I'll remove 12 out of it. So I'll get 64793. Now with this number again, I'll remove the last number, that is 6. So second step will be your 6 into 2, that is 12, and the rest of the number 3974 minus 12. So again 2693. Again I'll remove the last digit number, so that is your 2 into 2. I'll get 4, and the number is 396 minus 4. I'll get 392. Again I'll remove the last digit number, that is 2 into 2, that is 4, and 39 minus 4. See, we are getting the answer right over here only, 35. Now 35, it is divisible by 7, right? 7 5 is 35. So this number is going to be divisible by 5, but for the sake of completion, you can complete this number as well. So what I'll do is I'll take the last digit number, but again it will be left by 3, so it doesn't make any sense. 35 is what I am getting, and 35, it is divisible by 7. Right? I'll get it is divisible by 7. So this entire number is divisible by 7. Right. So this is the entire procedure. You are supposed to first of all remove the last digit number, multiply it by 2, and subtract it. Remove the last digit number, multiply it by 2, and subtract it. Remove the last digit number, multiply it by 2, and subtract it. Remove the last digit number, multiply it by 2, and subtract it. Right. So this is a procedure that we repeat every time until we get the last number which is divisible by either divisible by 7 or it is 0. Right. Next is your, so with this we complete this 7. Then let's talk about 8. So it's similar to 8 is similar to what we had done in 2 and 4. So yes, can anyone tell me what was the divisibility test of 2?
Unit digit will be even number.
Last digit is 0, or it's divisible by the last unit is 0246.
It is 02468. That is even number. In case of 4, yes, what we did is the number unit digit should see the last 2 digits should be divisible by 4. In this case, we talked about the last digit divisible by 2. In this case, we talked about last 2 digits divisible by 4 or 00. So if I go for 8, again, I'll take last 3 digits. So in this case, the last 3 digits, right? In this 1 digit, in this 2 digit, in this I'll get 3 digits. So last 3 digits should be divisible by 8, or they should be 000. Right? They should be 000. Now next one is 9. Now similar to 3, again sum of the digits. The sum of the digits should be divisible by 9. Instead of 3, it is 9 over here. So 3 and 9, they goes like this. 10, you know, the last digit should be 0, and we'll complete it with 11. The last, I'm not going beyond 11 because beyond 11 also there are certain tests, right? There are certain divisibility tests beyond 11 also. But if you get such kind of questions beyond 11, you can use calculator in that case. That is what I prefer, right? So in case of 11, what you are supposed to do, you are supposed to find out the sum of digits at even places of the number, and you're supposed to subtract it with the sum of digits at odd places, at odd, right? So this is something. Now if you get this answer to be either 0 or 11, your number is divisible by 11, right? Let's take an example. Again, I need one volunteer who has a calculator with them. Anyone?
Yes,
Yes, sir.
sir.
Okay, let's change its time. Yes, what you are supposed to do is you are supposed to take 7-digit number and multiply it by 11. Any 7-digit number you can take, and you have to multiply it by 11 and tell me the answer.
Sir, after multiplying the number with 11, I got 81,
8 1
53,
5 3
84,
8 4
85,
8 4. That's it, right?
84, 85, 93,
9 3
593, sir.
5 9 3. Right. Right. So this is the number you are getting.
Sir, remove that 84, only 5, 8593 at last.
8 5 9 8 5 9 3. Let's go to the next slide. Can you repeat the number, please?
Yes, sir, sure. 81,
8 1
53,
5 3
84,
8 4
85,
8 5 9
93.
9 3. Okay. So what I'll do is I'll divide these into two parts. First, the number at the even places, the second number at odd places. So let's take these numbers first. So I'll get 8 plus 5 plus 8 plus 8 plus 9. Right. The second I'll get the numbers at even places. So let's talk about them. Uh, this, and this minus 1 plus 3 plus 4 plus 5 plus 3. Right. So certainly it should be it's a number which is divisible by 11, right? So you'll get 8 5 13 and 8 21 and 8 29 and 9 38. This is your, you get 38, and 4 3 7 1 8 8 5 13 and 16. So this you'll get 6. Right. So 38 minus 16, you'll get 22, and 22 is a number which is divisible by 11. So this entire number will be divisible by 11. So instead of dividing the entire this kind of number by 11 and finding out the answer, you can simply find out the answer by adding the digits as even places and subtracting it from the sum of the digits at odd places. Right. So this was about cyclicity and divisibility. There is one more topic that I'll cover before moving on to the questions. Although that topic is not much important, but yes, in certain cases you may find it easy to use those kind of things, and it is known as inequalities. What do you mean by inequalities? Where the numbers are not equal, that they are either less than or greater than, less than equal to, or greater than equal to. So there's certain case related to inequalities that we are going to discuss. First of all, if let's say there is a number a which is greater than b, and there is another number c greater than 0. So if I use this equation, and if I add a c on both the sides, I'll get a plus c is going to be greater than b plus c in case of addition. So this is the first result I can deduce. The second result I can deduce if I uh, multiply them. So if I multiply c on both the sides, then also ac will be greater than bc. And the third result that I get out of is if I divide c on both the sides, then a by c will be greater than b by c. Right. So if the denominator is common, then the fraction with the highest numerator becomes the greater one. Simple. If you have common factor, then also you can find out this number is greater than the other. Now, let's say if you have another condition like if a minus c is greater than b. So you can simply solve this as you can take this thing on the other side of b, assuming there is an equal to sign. Right. So this will be equal to a greater than b plus c. Right. And again, you can also take b on this side. So you will get another result, that is a minus b is greater than c. And yes, in case if you want to change the sign over here, then this inequality sign also changes. For example, it's like this, and if I change the sign, if I make a negative and b positive, I'll make a negative and b positive, so this becomes b minus a. In that case, the sign also changes from greater than to less than, and it becomes c. Right. So changing the sign on one side, it also changes the sign of inequality. Right. This is the result of changing sign. Right. Let's take the next case. If a is greater than b, then there is an important result. What happens when I take the reciprocal? So if I divide the reciprocal, in that case, the inequality sign, it changes. Let's take an example 3, or I'll take 4. 4 is greater than 2, but 1 by 4 is less than 1 by 2. Why? Because 1 by 4 is 0.25 and 1 by 2 is 0.50. Right? So 0.25 is less than 0.50. Another result which is important, if okay, this we have done, not an issue. Yes, we can do this. If x is a number, x is a positive number, then, and obviously yes, next thing is and a is less than b. In that case, a by b becomes less than a plus x upon b plus x. Right. For example, if you want to find out, let's take the example over here. If you want to find out which digit is greater, 3 by 4 or 4 by 5. Yes, which digit is greater out of this? So instead of finding out the LCM and solving this, what you can simply see that 3 is increased by one number 4, and 4 is increased by one number 5. So the x in this case is going to be 1, because we are adding 1 to the numerator and the denominator to get the another number. So number which is a and b over here, which is the smaller one without adding, that will become smaller. So over here this sign holds true, right? Because 3 plus 1 and 4 plus 1 will get 4 by 5, right? So this is the case we are getting. Yes. And yes, one more thing that we use sometimes, that solution of a quadratic equation. Although in most of the cases we try to use the middle term split technique, but yes, in certain cases you should be aware of how to find out the roots of the equation, which is given by ax square plus bx plus c. The roots, the value of x is nothing but minus b plus or minus under root b square minus 4ac divided by 2a. Right. So this is the solution of the quadratic equation. I guess I have completed maximum of the things I have completed. If anything else which is required, we'll talk about them while solving some of the questions. So let's solve some of the questions for the day. Uh, and let's try to find out how we can use the things that we have studied so far. Right. So we are supposed to find out the unit digit of an expression which goes like this. 21 cross 22 cross 23 cross 24 cross 25 cross 26 cross 27 cross 28. Yes. What will be the unit digit of this expression?
0.
Very good. That was good. Yes, that's correct. So basically, how do we find out? We'll take the unit digits, we'll multiply them, and what will be the result of this multiplication? That will be the result of the unit digit of this entire multiplication. So instead of multiplying the numbers, we can simply multiply the unit digits also. But in this case also, if you see 5 into 2, if I take these two numbers, you know that 5 into 2 is 10. So 10 is going to stay whatever you multiply, wherever you multiply. So this 0 is going to stay over there. So unit digit becomes 0. So if any of the expression unit is being asked to you, and if you see two numbers being 2 and 5, the unit digit is going to be 10 for sure. Sorry, 0 for sure. Okay. Let's take the another number, another question, not number. Yes. So if sum of digits of a two-digit number is 10, and when the numbers are reversed, the number decreases by 54. You're supposed to find the number. Yes, let's try to solve this.
You
82, sir.
That's correct. Very good. Now, I'll tell you two methods to solve this question, and you are supposed to decide which one is easier, right? So first of all, we'll use this first line, that sum of digits of two-digit number is 10. So I'll take x plus y equal to 10. So the two digits are x and y. When the numbers are reversed, so when I'm reversing the number, that basically means earlier it was, let's say 10x plus y, number was 10x plus y. But when I reverse the numbers, in this case, I'll multiply 10 plus y into x. How this goes? It goes simply like if you have any number, let's say 27. So it was 20 plus 7 earlier. Now, if I reversing the digit, it becomes 72. It becomes 70 plus 2. Right. So the first digit that you're multiplying by 10, and the second digit you are simply adding. And when reversing the number, you are multiplying by 10 and then simply adding. Right. So this difference, it is given as 54. Or if you this, let's say this is equation number 1. Now if you solve this up, it becomes 9x minus 9y being equal to 54, or x minus y being equal to 6. This is your equation number 2. I got equation number 1, equation number 2. You can add them, you can subtract them. Let's add them first. Add 1 and 2. You get y will get cancelled. You'll get 2x equals to 16, or x equal to 8. Now if your x equal to 8, y will be 10 minus 8, that is 2. So your number is 10x plus y. 10x plus y, or 80 plus 2, that becomes 82. Simply. Now the second case, the second method that I'm going to share with you is, it's a trial and error method simply. So you know that x plus y is 10. So I'll find out the combination for which the sum is 10. So let's say if I take the unit digit to be 9, right? So 10 digit to be 9. The unit digit becomes 1, then 8, 2, then 7, 3, 6, 4, and 5, 5. Right. This is the first case I got. Now the second thing is, what if I reverse the numbers? In this case I get 19, in this case I get 28, in this case I get 37, in this case I get 46, and in this case I get 55. Now I will be finding out the difference. I know that the difference should be 54. For the correct answer, the difference should be 54. See, the first goes off, it will become 0. Right. So there is no point of finding this out at all. Right. So this becomes just 0. In this case, the answer will be 16. So this is not going to be the answer. In this case, the answer becomes 36, which is also not the answer. This becomes 54. Yes, this is the correct answer. And in this case, if you can see, it will become 72. Right? 72. So out of this, we know that after reversing, it decreases by 54. So after reversing, it decreases by 54. This happens only with this answer. Your correct answer is going to be 82. Right. This is just a trial and error method. Right. So if you're not confident, or actually if you're confident with this method that it will take a lot of time, you can simply adopt trial and error method and obtain the answer. Let's talk about the next question. Yes, this is an interesting question. We'll talk about how to solve this one. Find least number which, when divided by 12, 15, and 24, leaves 5 as remainder in each case. Right. So let's try to solve this one. Tell me how we can solve this. Yes, anyone getting the answer?
125.
Yeah, so that's the correct answer. Good. Now let's try to see how we can solve this number. You are supposed to find out the least number which, when divided by 12, 15, and 24, all these three numbers one by one, it reduces the remainder of 5 in each case. Now, first of all, to solve this kind of question, we are supposed to find out LCM. So we need to find out a number which is divisible by 12, 15, and 24, all of them. Right. So I'll try to identify LCM of 12, 15, and 24. Now we haven't discussed the method to try identify the LCM. So I'll be just explaining it once because this you have already studied. But again, just to brush up the basics, what we'll do is we'll take 12, 15, and 24 over here. First of all, I'll start with 2. So it will get 16 over here. 15 is not divisible by 2, so I'll keep it 15. And this will become 12. Again, 2. I'll get 3, 15, and 6. I can also take 2 once again. So this will get 3, 15, 3. Now I'll take 3. I'll get 1. 15 is divisible by 3, so I'll get 5 over here and 1. And at the end, I will get 5. So I'll get 1, 1, 1 over here. Now all the factors that I got over here, I'll just multiply them to find out the LCM. Right, so it will become 2 into 2 into 2 into 3 into 5. So 2 to the 4 to the 8, 3 to the 24, 5 is 120. So the LCM will be 120. So that 120 is the number which is divisible by 12, 15, and 24. Right. So it is divisible by 12. Yes. 12 tens are 15 8s are and 24 5s are. So we'll get 120. which is being divisible by all this. But we don't want it to be divisible, but we want a remainder of 5. So what I'll do is I'll add the remainder over here. The remainder is 5. So I'll get the number 125. Now 125 when divided by 12 will leave 5. 1 divided by 15 it will leave 5, and 1 divided by 24 it also leaves 5. Right. Now another question which is on HCF. So you are supposed to find out the HCF of two fractions, x square minus 5x plus 6 and x square minus 7x plus 10. Find out the HCF of these two things.
So x minus 2.
Yeah, that's correct. So what we have done is over here is we are supposed to find out the factors first of all. For to find out highest common factor, we need to find out the factors first. So let's try to find out the factors. X square minus 5x plus 6. We'll use middle term split technique. So it will become 3x minus 2x plus 6. Out of this, if we take common, you'll get x minus 3 minus 2, x minus 3, or it will become x minus 2, x minus 3. On the other hand, if you take x square minus 7x plus 10, this also becomes x square minus 2x minus 5x plus 10, or x minus 2 minus 5 x minus 2, or it will becomes x minus 2 x minus 5. So these two things, if you see, there is one thing which is common into these two expression, that is x minus 2. So your HCF will be x minus 2. Right. Again, let's see the next question. Oops. Just one. What do we get as remainder when 2 into 32, not 32, let's take it 2 into 29 is divided by 7. It's pretty simple question. See, how do we solve this kind of questions? First of all, you'll take 2 raised to 29. Now, remember the cyclicity of 2. Can anyone tell me what was the cyclicity of 2?
4.
4. Right. So I'll be using the cyclicity of 2. Cyclicity of 2 is 4. So I'll find out a number nearer to 29, which is a factor of 4. So 2 raised to 28 into 2. Now, if you take 2 raised to 4 raised to 7 into 2, right, this is similar. So 2 raised to 4, it cancels out after every 4, it repeats itself. So it doesn't count. So you'll get only 2 over here, right, as the answer. Now, when this 2 gets divided by 7, right, 2 gets divided by 7, what is going to be the remainder? Yes. When 2 gets divided by 7, the remainder will be 2 only. Yes, let's solve this question. Let me see whether you have got the idea of cyclicity or not.
1.
Okay, that was quick. Good. Let's see. So 3 raised to 27. Basically, the cyclicity of 3 is
4.
4. Right. So 4 I'll take, and I'll find a number which is nearby this. So
3 raised to 24 into 3 raised to 3.
yes, that's correct. 3 raised to 24 into 3 raised to 3. Now this will get cancelled out because after every 4 it is going to repeat. So 3 into 3 into 3, that is 27 divided by 8. So when 27 is divided by 8, what is the remainder that you get?
3.
3. So the answer will be 3. Fine. So this will be the remainder. Let's try to do the next question. Let's have one question related to divisibility test. So if a number a 4 8 9 is divisible by 11, find it.
5.
Very good. That's correct. So what we have is we'll take the number at even and odd places. So a plus 8 minus 4 plus 9. It should be either 0 or divisible by 11. Right. Or basically what I have is a plus 8 minus 13 or a minus 5. This number either should be divisible by 11 or it should be 0. Right. So I'll take first of all divisible by 11. Is there any number less than 11, less than 10, a unit digit number which is divisible by 11? No, that is not the case. So it should be equal to 0. So in that case, I'll get only 5 as an answer. There's only one possibility. Great. Again, I'll take the similar case A489. If it is divisible by 3, then find it.
0, 3, 6, 9.
Very good. Yeah, that's that's correct. So you can have 0. See, how does it comes? First of all, I'll add all the numbers and see what is the answer I'm getting. So I'll get 4 plus 8 plus 9. That is 9, 8, 17, and 21. So 21 is divisible by 3. So in case of A, I can find out the number which is divisible by 3, either 0 or 3 or 6 or 9. Right. So any of this number will do. Fine. Let's take the another case. Find the unit digit of 2 raised to 223. Yes, these two questions, let's try to solve them.
First one is 8.
First one is 8.
Okay, good.
Second one is 2.
That's correct. And let's try to see how we can solve this. So I have 2 raised to the power 223. I'll try to find out a number nearer to 223, which is divisible by 4. Now, यहाँ पर we are using two things, right? Cyclicity as well as divisibility. So we know that divisibility test talks about that the last two digits when dividing by 4, the last two digits should be divisible by 4. So over here, I need to focus on last two digits only. So 20 is the number which is nearer to this by. So I'll take 220, and the left number is 2 raised to 3. Right. So this again is going to cancel out because the cyclicity is 4. So I'll be left with this one. So 2 into 2 into 2, that is 8. So 8 will be the uh, unit digit. Over here, 122 in raised to power 122 into 133 raised to the power 133. We are not at all interested in 122 12 or 12 in the other places. We are only interested in these two. The cyclicity of 2 and 3, both of them are uh, 4 only. Right, so I'll use that part. Number nearer to 122 divisible by 4 is 120. So I'll take 122 into raised to power 120 into 122 raised to the power 2 multiplied by again 130. I'll get 132. So 133 raised to the power 132, which is divisible by 4, and 133. That is what I'll get. So this and this, they do not contribute anything to the unit digit. Over here, I'll get 2 into 2, 4 multiplied by 3 from this part. So 4 into 3 is 12. Again, the unit digit becomes 2. Right. So this is how we find out the unit digit of any of the complicated the expressions. And I guess we'll keep it up to here for today's session. I'll share some more questions for you to practice by tomorrow morning, so that you can practice, and we'll meet in the next class. Now, if you have any doubt, you can ask, or you are free to leave. Thank you so much.
Thank you, sir.